Good morning, pre-calculus. Today we are going to start an add-on unit. This is stuff that you need to know for calculus, but they don't go over it in pre-calculus or algebra 2 or algebra 1. So we're going to talk about it in its own little section. Make sure that you do the Google Forms that are associated with it. It will, if you're an at-home learner, it will count as your APEX in your APEX grade. And if you're an in-person learner, it will, of course, count as part of your grade. So first thing we're going to do is review substitution when we're solving systems of equations. So for substitution, we want to try and get either an x or a y by itself. So I'm going to go on ahead and get this y by itself by adding y to both sides. And I get 2x equals y minus 1, and then I'm going to add 1 to both sides. So I get 2x plus 1 equals y. So now anywhere I see a y in this equation, I can plug that in. So that's what I'm going to do. So x squared plus 4x minus 2x plus 1. And make sure you put this in parentheses so that you do not forget to distribute this negative sign. Okay, equals 7. All right, so x squared plus 4x minus 2x minus 1 equals 7. Okay, so this is a quadratic, so we're going to go in ahead and get everything over to the same side and combine our like terms. So we need to subtract 7 from both sides, and we need to combine these. So we wind up with x squared plus 2x minus 8 equals 0. Okay, so now to solve this, we're going to go on ahead and factor. So negative 8 and 2, and you can use your A times C method. You use whatever method you are used to using, of course. So I know that that is going to be a positive 4 and a negative 2. So now I'm going to solve those, and I get x equals negative 4 or positive 2. Now I'm going to go on ahead and plug those back in, and I'm just going to plug them back into this 2x plus 1 equals y. So 2 times negative 4 plus 1 equals y, and 2 times 2 plus 1 equals y. Okay, so negative 8 plus 1 is negative 7 equals y, and here 4 plus 1 is 5 equals y. So I know now that my two places where these cross, so this is a parabola and this is a line. So where these two shapes cross is going to be at negative 4, negative 7, and at 2, 5. So those are my solutions. I could check those by plugging both of those back in. Okay, so now we're going to look at elimination. So elimination is where we're going to multiply and then add these two equations to get rid of either the x or the y. It doesn't matter which one you do. I'm just going to go on ahead and get rid of the, let's get rid of the y in this case. I'm going to multiply this by 4. And I'm going to get rid of the y, so I need to multiply this by 3. So I'm going to get a negative 12 here and a positive 12 there. Okay. So that is going to be 20x plus 12y equals 36. And this bottom one is going to be 6x minus 12y equals 42. Okay, so now I'm going to get 26x. These are going to cancel, and that's going to equal 78. And I'm going to divide both sides by 26, and I get x equals 3. So now I'm going to go ahead and plug 3 back into either one of these equations. So 5 times 3 plus 3y equals 9. 15 plus 3y equals 9. Subtract 15 from both sides. 3y equals negative 6. So y is going to equal negative 2. So my answer then is going to be 3, negative 2. Okay, I'm going to go on ahead and check this one just to remind you guys how to check. Okay. So what I have to do is I have to plug this point back into both of these. So I'm going to start with the first one. So 5 times 3 plus 3 times negative 2 equals 9. Well, that's 15 minus 6 equals 9. So 9 equals 9. That means it checks. But remember, you can't just plug it into one. even if you get the right answer and think that it's correct, you have to plug it into both of them and make sure this point works in both of these. So now I'm going to do 2 times 3 minus 4 times negative 2 equals 14. So that's going to be 6 plus 8 equals 14. Okay, and 14 equals 14. So that checks. So we know 100% that that is correct. Okay. So let's recall that there are 3 possible solutions for a system of linear equations. Okay, there is exactly one solution, which would be called consistent. So that is where you just cross and they touch at one spot. There is no solution, which is called inconsistent, and that's if they are parallel lines, so they never touch. And then there are infinitely many solutions, and that's if it's the same exact line, but maybe they're written in different forms. Okay. All right, so now we're going to go on ahead and look at solving systems with 3 equations and 3 unknowns, or with 2 equations and 3 unknowns. Okay, so the first one says use back substitution to solve. So with this one, I already know that z equals 2, and I can see that this equation only has 2 unknowns. So I'm going to plug this z into this equation with only 2 unknowns to find my y. So I'm going to get y plus 6 equals 5. So I get y equals negative 1. Okay, well, now I know my y and my z. So now I can plug both of those into this equation and solve for x. So now x minus 2 times negative 1 plus 3 times I know z is 2 equals 9. X plus 4 plus 2 plus 6 equals 9. Okay, so x plus that's 8 equals 9. So x is going to equal 1. So my answer here, it's going to be written as a coordinate, just like we've been doing. It always goes x, y, z. Okay, so that's going to be 1, negative 1, 2. So that is my answer. Okay, and when we're talking about the z-axis, so we have our normal x and y-axis, and then our z-axis is a third dimension that is normally like coming out at us, sort of. Okay. And you'll start dealing with those a lot more once you get into higher level calculus classes. Okay, let's go on ahead and take a look at this next equation. So this one is not going to be quite as easy because we don't know any one answer. So I can see that this one only has 2, an x and a y. So what I'm going to do is I'm going to combine these 2 equations, and I'm going to get rid of the z, because that's what this middle one is missing. Okay, so let's go on ahead and do that. So I'm just going to rewrite them. X minus 2y plus 3z equals 9. 2x minus 5y plus 5z equals 17. Okay, so I have to get rid of the z. So I'm going to multiply this top one times negative 5, and that'll make that negative 15z. And I'm going to multiply this bottom one times 3, and that'll give me 15z. All right, so I'm going to rewrite those now that I've multiplied them. So it's going to be negative 5x plus 10y minus 15z equals negative 45. Now my second one is going to be 6x minus 15y plus 15z equals 51. All right, I'm going to go on ahead and I'm going to combine my like terms. Okay. So I'm going to add these 2 equations together, and I get 1x minus 5y equals 51 minus 45, which is 6. Okay, so now I have this equation and this one, which are 2 equations with 2 unknowns. Okay. So now I'm going to combine those 2 equations. So I have my x minus 5y equals 6, and I have this one from up here, x, negative x plus 3y equals negative 4. And now those cancel. Negative 2y equals 2. So y equals negative 1. Now that I know what y is, okay, I can go on ahead and plug it back into either one of these equations. I'm going to just go on ahead and plug it back into this one. So negative x plus 3 times negative 1 equals negative 4. So negative x minus 3 equals negative 4. So I'm going to add 3 to both sides, and I get negative x equals negative 1. So x equals positive 1. So now I know my x and my y, and I can plug those back into either one of these equations, okay, to get my z. So I'm just going to kind of write my steps here. So 2, then I did 3, then I did 4. I'm going to come up here and do 5. Okay. And I'll do it in purple, I guess. All right, so now I know my x. My x is 1. I'm just going to plug it into the top equation because it looks like the easiest one. My y is negative 1 plus 3z equals 9. Okay. So now I have 1 plus 2, which is 3, plus 3z equals 9. So I get 3z equals 6 when I subtract 3 from both sides. Divide both sides by 3, and I get z equals 2. Okay, so my answer here is going to be 1, negative 1, and 2. And it just happens to come out the same. That doesn't mean anything. It wasn't planned that way. It's just the way it happened. Okay. You can check these the same exact way. You just have to make sure that you plug this point into all 3 equations to make sure that it makes all 3 of them true. All right, so now we're going to get into something called row echelon solving. Okay, so this one is where we're going to combine different rows together in different orders, and we will wind up with an answer. Okay, so let's go on ahead and start. And I always do this the same way. It just makes it easier to focus. So I always combine 1 and 2 first. So I'm going to write that out here, 1 and 2. And if you write it out there, it also makes it easier to see what you're doing and what you've already done. So x minus 3y plus z equals, not negative 1, equals positive 1. And then we have 2x minus y minus 2z equals 2. Okay, so we can combine these, and I'm just going to get rid of the z's here because that'll make it easy if I just multiply this by a positive 2. So that'll give me 2x minus 6y plus 2z equals 2. All right, so now I'm going to combine these two. So that's minus, not an equal sign. Okay, so I'm going to wind up with 4x minus 7y. Those go away, equals 4. All right, so here's something really important, and I always do this the exact same way also because then I know exactly how I'm doing it every single time without having to think about it. Now this equation is going to become our first equation. Okay, so we're going to replace this with this one. And I'm just going to rewrite this entire system. So 4x minus 7y equals 4. Okay, so I'm rewriting the system here. The other two stay the same. So 2x minus y minus 2z equals 2. And x plus 2y minus 3z equals negative 1. Okay, so this is where I said I always do this exactly the same way. The next two I'm going to combine are going to be 2 and 3. Okay, and I'm going to write that here, and I always do so that I know exactly what I'm doing. So now I'm combining 2 and 3. So 2x minus y minus 2z equals 2. X plus 2y minus 3z equals negative 1. And when you're doing this, you should always get in the habit of looking for getting rid of at least one of the same thing. So if I got rid of z in this one, I'm going to try to get rid of z in this one. So I'm going to go on ahead and get rid of the z. And in order to do that, I have to multiply this top one by 3, and the bottom one I'll multiply by a negative 2. Okay, so that's going to give me 6x minus 3y minus 6z equals 6. Okay, and then it's going to give me negative 2x minus 4y plus 6z equals 2. Okay, so those are going to go away, and I'm going to wind up with 4x minus 7y equals 8. Okay, so now I've got this second equation. All right, so now I'm going to do the same thing I did before, and I'm just going to rewrite my system. And now this, so this one became my number 1. This one's going to become my number 2. Okay, so my system now is going to be 4x minus, so I'm starting with this system that I rewrote already. And now I'm going to put this one in, 4x minus 7y equals 8. And then I have x plus 2y minus 3z equals negative 1. And you see, I have 2 systems with 2 unknowns. Okay, so I don't need to worry about this third one right now. I'm going to go on ahead and combine these 2 again. Okay, now that I've gotten to where I have two equations with 2 unknowns. So I have 4x minus 7y equals 4. And I have 4x minus 7y equals 8. Okay, so to combine these, I'm just going to multiply one of them times negative 1. Okay, so I'm just rewriting this top one first. And now I'm going to write this one, negative 4x plus 7y equals 8. Okay, that goes away, and I get 0 equals negative 4. Okay, so looking at that, that is never going to be true. That means that this is no solution. These 3 lines will never intersect. Okay, so they might be in different planes or something. And if you notice at the top, it says it's an inconsistent system. And remember, inconsistent meant the same thing as they will never intersect. Okay, so we're done with that one. It's no solution. Okay, so if you get to a point where the 2 sides don't equal, or even, once you got to this point and you said, well, 4x minus 7y equals 8 and 4x minus 7y equals 4, that's not possible. These numbers, if they're exactly the same, can't equal 2 different values. And then you could go on ahead and say you're done, okay, and put no solution. Okay, that's our answer. All right, so now we're going to take a look at a consistent and dependent system. Okay, so we're going to start exactly the same way. So the first thing I always do is combine numbers 1 and 2. So 1 and 2. So x plus y minus 3z equals negative 1. And I get y minus z equals 0. Okay, so I'm going to go on ahead and combine those. See, if I multiply this one times a negative 1, then I'm going to be able to get rid of it pretty easily. So negative y plus z equals 0. Right, so that's going to cancel, and I'm left with x minus 2z equals negative 1. Okay, so now, like I said, I always do the exact same thing. So now this is going to replace my number 1 equation. So x minus 2z equals negative 1. Okay, so x minus 2z equals negative 1. We have our second equation, which is y minus z equals 0. And then we have our negative x plus 2y equals 1. All right, so this is now our new system. So once again, we don't even deal with that one anymore. Okay, just like in this one, we started dealing with this one and then we moved it to this one. Okay, so this is our new system. That one no longer applies. Okay, so now the first thing I did was 1 and 2. The next thing I always do is I combine 2 and 3. So 2 and 3. All right, so y minus z equals 0 and negative x plus 2y equals 1. Well, the only thing I can get rid of here is the y's. So I'm going to multiply this by negative 2. So I get negative 2y plus 2z equals 0. And I'm going to combine those. So that and that go away. And I'm left with negative x plus 2z equals 1. Okay, so now just like I've been doing, I have to write my new, see, I'll write this one in purple. I have to write my new system. So my first equation I had already replaced, so it stays. Okay. My second equation is the one that I'm going to replace this time. Okay, so that's going to be replaced with this. So negative x plus 2z equals 1. And then my third equation stays what it was in my last one, 2y equals 1. Okay, so we never replace the same one twice. So that's once again why I'm always doing this in a particular order. Okay, so now I'm going to combine 1 and 3. I've combined 1 and 2. I've combined 2 and 3. Now I have to combine 1 and 3. Okay? And if you stick to this just same order every single time, it makes life a whole lot easier. Okay, for the most part. There's some times when you vary, but not very often. Okay. All right, so let's go on ahead and combine 1 and 3. So we get x minus 2z equals negative 1. And negative x plus 2y equals 1. All right, so now we're going to wind up with 2y minus 2z equals 0. Okay. So now that we've combined that, let's go on ahead and rewrite our system. Okay, so our new system, we had already replaced our first one. We had already replaced our second one. Now we're going to replace our third one, 2y minus 2z equals 0. Okay, so now that we're at this point, now we can see what can we cancel. So what two can we combine and get an actual answer? Okay, well, these two both have x's and z's, so I'm going to combine them. So x minus 2z equals negative 1, and negative x plus 2z equals positive 1. So if I combine these, that equals 0, that equals 0, and that equals 0. So I get 0 equals 0. That means that this is a consistent system. Okay, it also means it is going to be a dependent system. Okay, what that means is depending on the value of x, the values of y and z will change. Okay? So now we're going to go on ahead and show you how to find that. Okay? So I'm going to look at my original function now. And you don't do this a whole lot, but because we know that this means that it is a consistent dependent system, we're going to go back up here. And you see this one where it says y minus z equals 0. We're just going to solve it, okay, and get either y or z by itself. Well, in this case, y equals z. So we're going to call each of these a. Okay? So our values for y and z are going to be some value a. We don't know what that value is. Okay, we just know it's going to be some value. And based on whatever y and z are, x is going to be a different value, or it might be the same. Okay? So now we have to figure out, well, what is our x value going to be? So now I'm going to go on ahead and plug this in. We'll just plug it into this one right here. So x minus 2z, which is a, equals negative 1. So now I'm going to add 2a to both sides. And I get x equals 2a minus 1. Okay? So my solution for x is 2a minus 1. Okay? So that means that these are lines that are the exact same lines. They're going to overlap. So it doesn't matter what the values are. They're always going to be this pattern right here. Okay? So that is probably one of the harder ones to do. Okay. All right, let's take a look at another one. This one doesn't tell us if it's inconsistent or consistent, but I wanted to show you an example of both of those because those two that we just did are two of the more interesting ones. Okay, so let's do a couple where we'll actually get some answers. Okay, so I'm going to start the same way I always do. I'm going to do 1 and 2. Okay. So I'm going to have x minus y plus z equals 4. I'm going to have x plus 3y minus 2z equals negative 3. Okay, it doesn't matter what I get rid of. I can decide what I get rid of. I think I'm going to just get rid of the x's to start. Okay, because they look like the easiest one to do. So I'm just going to multiply this by negative 1. So I get negative x plus y minus z equals negative 4. That goes away. 4y minus 3z equals negative 7. Okay. So now that becomes my first equation in my new system. So I have 4y minus 3z equals negative 7. Okay. So now I'm going to just rewrite this whole system. So my next two stay the same. So 3x plus 2y plus z equals 5. So there is my new system. So I'm done with that one. Okay. So now step 2, I'm going to combine 2 and 3. All right, so 2 and 3, x plus 3y minus 2z equals -3. And I get 3x plus 2y plus z equals 5. Okay. And in this case, I think I will get rid of the x again, just because it looks pretty easy. So I'm going to multiply this by -3. So I get -3x minus 9y plus 6z equals 9. Okay, so that's going to go away, and I'm left with -7y plus 7z equals 14. And now I'm going to rewrite my system. Okay, so my system is going to be 4y minus 3z equals -7. So remember, I'm using this one now, not this one. Okay, my second equation, I'm going to replace with this, -7y plus 7z equals 14. And then I'm going to rewrite my last equation. So 3x plus 2y plus z equals 5. Okay, so now I've done 1 and 2. I've done 2 and 3. Now I need to combine 1 and 3. Okay, so 1 and 3. Right, so I have 4y minus 3z equals -7. And I have 3x plus 2y plus z equals 5. So in this case, it looks like it'll probably be easiest to get rid of the z's. So I'm going to multiply this by 3. And so now I get, I'm just going to rewrite the top one so that I can combine them easily in a minute. Okay, so 3 times 3, I get 9x. 2 times 3 plus 6y plus 3z equals 15. Okay, so my z's are going to go away, and I'm left with 9x plus 10y equals -7 plus 15 is 8. Okay, so now I'm going to rewrite my system again. Okay, so these two are going to stay the same, and I'm going to replace my third one this time. So 4y minus 3z equals -7. -7y plus 7z equals 14. And I'm going to replace this with 9x plus 10y equals 8. Okay, so now looking at these, I need to see which two can I combine to get an answer for an x, y, or z. Okay. So if I combine these two, I can get rid of either the the y or the z, and I can solve for one of those. So I'm going to do that next. Okay. So 4y minus 3z equals -7. -7y plus 7z equals 14. Okay, well, in this case, I'm gonna, if I'm using, right, I could solve using substitution, or I could solve using elimination. Since I've been using elimination, I'm just gonna keep doing that method. Okay, whichever method works for you is fine. Actually, you know what? Let's, this one looks like it would be easy to get rid of. So let's see. So if we add 7y to both sides, we get 7z equals 14 plus 7y. And if we divide every term by 7, and so that's the only reason I did this, because I saw that these would all be divided by 7 really easily. We don't want to do it where we're working with fractions. So z is going to be 2 plus y. Okay, so now I'm going to go on ahead, and I'm going to, I've got this, so I'm going to plug this back into one of these. So 4y minus 3 times, we know z is 2 plus y, equals -7. So 4y minus 6. Let's see, 4y minus 6 minus 3y equals -7. So I'm going to have y minus 6 equals -7. So y equals -1 in this case. Okay, now I know what y equals. Now I'm going to find out what z equals. Z equals 2 plus -1. So z equals 1. Okay. And then I have to find my x value. So I'm going to use whichever one. I'm going to go on ahead and use this one right here because it looks like it's the easiest. Okay, and I could go back and I could plug this into any of these. I could go all the way back to the beginning if I wanted and plug these x's and y's back into these. But since I've already isolated them, I can use these ones. Okay? So now I'm going to use 9x plus 10 times my y, which is -1, equals 8. And I get 9x minus 10 equals 8. 9x equals, add 10 to both sides, that's 18. So x equals 2. Okay, so now my final answer is going to be 2, -1, 1. Okay. It does take some room. It does take some thought, but once you get there, then it makes life a whole lot easier. All right, so let's go ahead and look at this one. So this one has 2 systems with 3 unknowns, but you'll notice if I go on ahead and combine those, then I wind up with x minus 2y equals 2 and 2x minus y equals 1. Okay, so I wind up with those 2 different equations. Okay, so all I did really was, yes, I added them together and I canceled out. Okay, but I didn't actually have to add them. Right, I was able to just cancel out the z's and keep this the same. So x minus 2y equals 2 and 2x minus y equals 1. Now I can combine these two and I can figure out one of my answers, my x or my y. I'm going to go on ahead and multiply this times -2. So we get -2x plus 4y equals -4. Okay, now I'm combining these two. So I get 3y equals -3. So y equals -1. Okay, now that I've got that, I can start plugging it back in. So I'm going to plug y equals -1 back into this one right here. So x minus, and remember, it doesn't matter which one I plug it back into. X minus 2 times -1 equals 2. X plus 2 equals, oh, not equals 0. That's coming next. Equals 2. Okay. So that's a plus. I'm just making sure that I am plugging this back in right. Oh, wait a minute. What did I do here? Hold on. Let me double check my math here. -2, -1 plus 4y. Yep. So that's going to work out. Positive 4y. 3y equals. I'm just making sure that I did my math right because something looks weird here. Okay. So now when I do that, I am going to go on ahead and do -2 minus 2. So x is going to equal 0. Okay, so now let's go on ahead and plug x back in and y back in to get our z. So 0 minus 2 times -1 plus z equals 2. Okay, so I'm going to have 2 plus z equals 2. Subtract 2 from both sides, and I get z equals 0. So my answer then is 0, -1, 0. Okay. And once again, you could double check it by plugging all 3 of these back into both and making sure that it works. Okay. All right, let's go on ahead and take a look at 2 more. Okay. These take practice, so we're going to look at a couple more. All right, so this one right here, I'm going to go on ahead and combine these 2. So this one, same thing, I can get rid of the z's. Okay, so I'm going to rewrite it. X minus 2y equals -5, and 2x plus y equals 5. Okay, I got to get rid of one of these. It doesn't matter which. Let's go on ahead and get rid of the y because they're already opposite signs. So I'm going to rewrite the first one. And now I'm going to multiply this. So I get 4x plus 2y equals 10. Okay, now I can combine them. I get 5x equals 5, so x equals 1. Okay, now I'm going to plug this x equals 1 back into either one of these equations. So 1 minus 2y equals -5. So subtract 1 from both sides, and I get -2y equals -6. Okay, so I get y equals 3. And now I'm going to plug x and y back into either one of these. So 1 minus 2 times 3 minus z equals -5. So that's going to be 1 minus 6 minus z equals -5. So that's going to be -5 minus z equals -5. Add 5 to both sides, and I get -z equals 0, which means z just equals 0. So my answer here is going to be 1, 3, 0. And let's do one more with 2 equations and 3 unknowns. So I'm going to cancel that. I get x minus 2y equals 2. And I get 2x minus y equals 1. Okay, so I'm going to go ahead and get rid of the x first. Okay. So if I multiply this by -2, I get -2x. Okay. Let's see. Plus 4y equals -2, that's -4. Okay. So that's going to go away, and I'm going to get 3y equals -3. So I'm going to get y equals -1. Okay, so now let's go on ahead and continue solving this. So now I'm going to plug this back in. So I'm going to have 2x minus -1. Okay, so make sure your y is -1, but there's a minus sign in front of it, equals 1. So I'm going to have 2x plus 1 equals 1. I'm going to have 2x equals 0, so x is going to wind up equaling 0. Okay, and then my last one, I'm going to plug in my x and my y. So x minus 2 times -1 plus z equals 2, and I'm just using one of these two. It doesn't matter which one. Okay, so that's going to be 0. That's going to be a positive 2 plus z equals 2. And I get z equals 0. So my answer there is 0, -1, 0. Okay. All right, so that is all for today on solving systems. Go on ahead and make sure that you do the Google Forms quiz on this, where you will have to be entering these answers. Okay. And let me know if you have any problems, and I'll see you next time.